We are going to be working in our linked int list class again. And last time we made the public void print and toString methods. The toString method really replaces the print method. We can just comment that out. It was kind of a stepping stone to go from print to this toString method. The toString method has more of format to it. It has these brackets and it prints it out all on one line, where the print would print it out in rows, or in separate rows. So it can be useful, but the toString is an easier, simpler way to print it out, more uniform way to print it out. Next, we are going to be adding another method. We are going to be adding a method that appends a given value to the end of a list. So we will be working underneath our toString method. When we start this method, we are going to have it as public void add. It's public for the same reason toString is public. And the reason why toString is public is so that when we have other code, when we have our main program, it'll be able to access these methods. And we want our front of a list private so that it can't be deleted, and we will always have the front of our list. So now we're going to be in our add method. It's void because it's not returning anything, and we're titling it add. It needs to take a parameter. This parameter is going to be whatever value needs to be added to the end of the list. So we're going to have it as an integer, and we're just going to call it value. Every time we have a method, we need to check if our linked list is empty. So we can really just copy this if statement, and we're checking if the front of the list is null. And then if so, we're not going to return anything. We are just going to set this value that we're given as the front of our list. Since our list is empty, it has no values in it. So that means whatever we're adding in is just going to be the front value, the only value. Now, if the list is not empty, we have our else statement, and we are just going to add it into the list. We're going to do this by making a temporary list and then making a while loop to get to the end of the list, because we have to go through every single value of the list. We can't just look at certain values. We always need to make a temporary list so that we don't mess with our original list and break it in some way. So we're going to declare a new list node, call it current, and we're going to set that equal to front. And that's going to take the front of our list. It's going to set it equal to whatever our list is. So if our list has the values 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 is going to be stored inside of current. Now we need to iterate through the index of this linked list until we get to the second to the last value. Once we're at that value, we can append our given value. So we're going to have while current.next does not equal null, and then we're going to have stuff inside of here that's going to do stuff. Since we need to get to the very last value, we are going to write current is equal to current.next. This way it's really iterating through our linked list and getting to the very last value. Once it's at that last value, it's going to break out of our while loop, and then we are going to add to it at the bottom. We're going to have current.next. So the next value that's null, we're going to make it our given value. This should be ListNode, and that's it. So a summary of this would be, we have a public add method. We're taking in the parameter value, and it's of type integer. If the list is empty, that means there's nothing in our list. We just have an empty list. The value that's being passed in is our only value. So if front is equal to null, if the list is empty, we are just going to set front equal to new list node and then the value. If the list is not empty, we are going to have to iterate through all of our list indexes to get to the very last value. What we're doing here is making a temporary list node so we don't mess with the original list. We are going to have it as a while loop so we can step over all of the values in our indexes. We need to step over all of our indexes because we're not removing anything, we're just adding something to the very end. So we have to go to the very end of our linked list. And we're going to have current.next does not equal null. So while the next value, really it'll look like this with the slash representing null. And while current.next, so while the next value, if we're at 3, well, this value is not null, this value is not going to be null, this value is not null, and only this value is null. So it's going to run until it hits 6. Once it hits 6, it's going to break out of the loop, and then it's going to look at the next value when it says current.next. So it's going to look at this value, which is currently null. If it was current, what it would do would overwrite this 6th value. But we're looking at the null value. And we're going to set it equal to a new list node. And this new list node is going to be value. This value, whatever value is passed in, it's going to replace the null part of our linked list. And that's how you append to the end of the list.